Welcome to homework.
Problems like problem number 58 are not the worst kind on account of them telling us what we're working towards. So we're eventually trying to show that the mass has a certain form, and we can first say that we can find the velocity of the ions using energy conservation. So the total electric potential energy of the ion is going to turn into kinetic energy as they're accelerated. So once they jump into the magnetic field and are moving perpendicular to that magnetic field, the magnetic force is going to be a maximum, which is going to give a circular path to them. So let's first do what I said first, of course, which is to take the potential energy from the electrical interaction and turn that all into kinetic energy so that we can find a velocity. All right. Now, well, we can do that first, or we can go to the force definition. Either way, we'll get the same thing. So we take the force due to a particle in a magnetic field and set that equal to the centripetal acceleration force all over, which is mv squared over r. Now, we have a choice here. We can either solve by energy conservation and plugging in over here, which could be what we decide to do, I guess. Or we can solve for this one over here. It's really up to us. I say let's go ahead and use this one. So we'll use one. Let's rearrange things so velocities cancel like that, and we get that our velocity is equal to QBR on M. Okay, now we plug that in right there, and you get that QV is equal to 1/2 M QBR M squared. Thus, we see it's equal to Q squared BR. Oh, sorry, all of these are squared. All on 2M. Sorry, this V is a voltage. Let me make that clear. Yeah. One of these Q's cancel. And we want to find mass in the end. So then rearranging stuff for mass gives us the quick substitution. And we see that our mass is Q R squared B squared all over 2 times the voltage. And if we check, yes, that is what we were expecting to get, where R is the radius of that path in the magnetic field and Q is the charge. So it's always nice when it works out that way.